For this assignment, we are going to graph each function, identify the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range of each function. So just like I taught you in the lesson, I'm going to go ahead and zoom in to question 1. And I would like for you to use your calculator. So go to the y equals screen, and let's go ahead and type in parentheses x plus 2 close parentheses squared minus 1. And what I like for each of you to do, or what I'd like for you to do, I'd like for you to make a table. And we're going to go to our table here by clicking second graph. Some of you asked me, where do I start graphing? It really needs to look at the graph and then look at the y value. In this case, negative 615 is too high on the y-axis. So we'll say negative 5 when x is negative 5, y is 8. When x is negative 4, y is 3. When x is negative 3, y is 0. When x is negative 2, y is negative 1. When x is negative 1, y is 0. When x is 0, y is 3. So we're going to go ahead and scroll one more. When x is 4, y is 8. So let's go ahead and zoom in here a little bit more. So we're going to go ahead and graph the first one. I'm going to use I'll use blue. So we have negative 5. So we start at the origin, go 5 spaces to the left, 1, 2, 3, 4, 5, and then go up 8, 1, 2, 3, 4, 5, 6, 7, 8. So there's our first point. We're going to start at the origin again. Go 4 spaces to the left. 1, 2, 3, 4. Then go up 3. 1, 2, 3. Start at the origin. Go 3 spaces to the left. 1, 2, 3. At 0. Start at the origin. Go 2 spaces to the left. Negative 2. Go down 1. And then start at the origin again. We have negative 1, 0. So you go left 1 and you stay right there. 0, you stay at the origin, go up 3. And then the next one is 1, 8. It's not 4, 8, but it's 1, 8. That should be 1. So 1, and then go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and connect the points. Connect the points. And then what you do is you're going to go ahead and draw your axis of symmetry. It's a vertical line. It cuts this in half. So we know that the x is negative 2. We know that the vertex is negative 2, negative 1. That's the vertex. 0, 3 is the y-intercept. And I know that it's asking for domain. Remember the domain, you're looking at going from left, the x values, all the way to the right. And so you notice that we have our domain starting from negative infinity to positive infinity, so that's going to be the domain. Negative infinity to positive infinity. The range is different. The range, the lowest part, is actually a negative 1 and it goes up. That's the range. So the range will be from the lowest y value, the minimum, which is -1, and it goes towards infinity. And this right here is also called the minimum point. Number 2, we're going to go ahead and graph that quadratic. So we're going to go ahead and start by placing this into the calculator. And you notice we already have something there, so let's just press clear. So we have -4 parentheses x minus 3 close parentheses squared plus 2. So just double check that we have the right equation. Now I'm going to press graph just so we can see what we're working with. Okay, good. So what I'm going to do, I notice that we can probably start with maybe 0 or 1. So let's look at the table. So 0 is -34. By the way, we can't graph that, but that's going to be the y-intercept. Okay, we can graph 2, -2. So I'm going to go ahead and make a table here. So I have 2, -2. Then the next one is 3, 2. Then I have 4, -2. And then I have 5, -14. I'm going to stop because it seems like we can't graph that, but let's go ahead and graph those order pairs. So we start at the origin 0, go 2 spaces to the right, and then go down 2. Then we have started the origin again, 3, 1, 2, 3, and we're going to go to 2. Okay. Start the origin again and go to 4, go down to -2. Then 5 is going to be -14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And if I had selected 1, it would have been also -14. So I'm going to go ahead and graph it right here. And you notice this is different because it opens downward. We do know that the graph is narrow. I'm going to go ahead and graph the axis of symmetry again. So x equals 2. Vertex is right here, vertex, which is 3, 2. It's also the maximum point. Okay. Let me erase this here. Domain. Domain is, we know that we start at the lowest x value, and then we approach the highest x value. So in this case, the domain is going to be -infinity to +infinity. The domain, on the other hand, the highest y value is 2, and then it goes down all the way to -infinity. So remember, when we're dealing with range or domain, we're dealing with the lowest, the minimum y value. In this case, it's -infinity, and the highest y value is 2. So the domain is from -infinity to +infinity. The range is from -infinity to 2. This is the vertex, 3, 2. This is the maximum point. Here is the graph. The y-intercept is when the x value is 0. We notice here that it's 0, negative 34, and I can't graph it. So I'm just going to write y-intercept 0, negative 34. For problems 4, 5, 6, and 7, you are required to graph the parent function, and then you're going to graph the function that it's illustrated or that it's written, and then all you have to do is describe the transformation as compared to the parent function. I do expect you to have two tables for each graph, and so we're going to start with number 4, and I'm going to zoom in. You don't have to redo the parent function table. Once you know what the parent function table is, you can just use it, reuse it over and over again. So I'm going to go ahead and start with number 4. And I'm going to go ahead and zoom in with number 4. And I'm going to go ahead and illustrate the parent function here. So we have y equals, the parent function is where all these functions are going to derive or come from. So you have x squared. And I'm going to graph it. That is the parent function. We're going to look at the table. And we're going to start with negative 3. And if you want, you can just write here on the side. So we know that this is the parent function. And you don't have to redo it over and over again. So I have negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. So you'll probably memorize this, and you'll just reuse it over and over again. So now here I'm going to use red to denote the parent function. So we have negative 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. It becomes automatic. 3, 9. Of course, you want to draw that smooth curve. And here is the parent function. Now, when you're doing the assignment, I'm going to use blue so we can kind of distinguish the two graphs. And this is XY here. So we're going to go to our graph. And if you want to understand what's actually happening, I recommend you going to your TI-84 and use this button right here. Kind of tells you what's occurring. And we're going to go ahead and press x squared plus 4. And just so you can see what is occurring, I'm going to let it graph. You see that? And so we know that the function did increase or did move up. So in order for us to see the table, I'm going to go ahead and unselect the parent function just for right now. Go to the table, and you notice that you probably want to start with negative 2, 8, negative 2, 8, negative 1, 5, 0, 4, 1, 5, 1, 5, and then we have 2, 8. And of course, I'm not going to graph that, so we have negative 2, and then we have 8, negative 2, 8, negative 1, 5, 0, 4, 1, 5, 2, 8, and you notice, and what you want to do is you want a written explanation. And that's what you have to write. The graph will shift up. We're on number 5, and once again, we have the parent function illustrated. You don't have to write the table for the parent function. Remember, it's negative 3, and I'm going to use red. Negative 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, you're always starting from the origin. Negative 2, go 2 to the left. Up 4, 1, 2, 3, 4. Start at the origin, go 1 to the left and 1 up. 0, 0, 1, 1, 2, 4, 3, 9, and then of course you want to draw your smooth curve. So there's the parent function. So now I'm going to use blue as the new function. And just so we know what's going on, I'm going to leave the parent function there, and then we're going to go ahead and graph that new function that we have. So parentheses x minus 3 squared. I'm going to press graph. Remember the feature that I asked you with that little, it seems like a circle. You want to use that circle there, you see, and then it's going to tell you what's happening. Okay, so if you want to write this down, the graph will shift to the right. Okay. If you want to look at the table, you're going to have to deselect the parent function, and then we're going to go ahead and look at our table. And you notice, whoa, it goes pretty high quickly. So we're going to start with 0, 9. So I'm going to write 0, 9. The next one is 1, 4. So 0, 9. Oh, my apologies, 0, 9. The next one is 1, 4. So it's 1, 4. Then we have 2, 1. And I'll write 2, 1 over here. 2, 1. The next one is 3, 0. 3, 0. 4, 1. 4, 1. 5, 4. 5, 1, 2, 3, 4, 5, 4. And then 6, 9. 6, and then up 9. And of course I'm using different colors so you can kind of see the difference. And you notice the vertex did move. Actually the whole graph did move, and it was a shift to the right. What I'm going to do is I'm going to go ahead and do number 6 now. Go ahead and type in x minus 2 squared plus 3. And you notice I didn't select the parent function, so I'm going to go up there and I'm going to go ahead and select it just so you know what's going on. And I'm going to change that to that circle. Then I'm going to graph it. Okay, so actually two things occur. If you want to write that down, what are the two items that occur? The graph shifts right 2 units, in fact, and shifts up 3 units. Okay, so we're going to go ahead and graph that, and we're going to start with the parent function. What I'm going to do is I'm going to go to the table again, or the y equals, and I'm going to deselect the second one just so you can look at the table if you need to. Some of you might have this already memorized, but I'm going to have it up there. And we said we start with -3. And remember, you don't have to retype or do this table over and over again. So you have -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, 4. -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and I'm going to go ahead and graph the points. Try to do a smooth curve as possible. And what we're going to do now is we're going to look at the table of the new function, and then we're going to describe the transformation. Let me go ahead and look at our table. You notice that we probably want to start with 0, 7. And I'm going to use the color blue to kind of make that distinction. So to distinguish the both. So we have 0, 7, 0, 7. 1, 4. 1, 4. 2, 3. 2, 3. 3, 4. You notice that right there it starts going up again. 3, 4. 4, 7. 4. And then we go up 7. We probably can go one more. Oh, nope. So I'm just going to go ahead and graph it just like that. Remember, you have to graph your points. So that's 4, 7. So there are points. And you notice it shifted 2 units to the right and then 3 units up.